This is the video for Chapter 4, Part 3. So let's take a look at an example, and we'll actually use this example all the way through all the different things that we could find for Chapter 4, both in Section 4.1 and 4.2. So the following data are based on a study for drilling rock. The researchers wanted to determine whether the time it takes to dry drill a distance of 5 feet in rock increases with the depth at which the drilling begins. So anytime I'm trying to figure out explanatory variable and response variable, usually what I'll do is I'll try to say which one can I adjust as the evaluator or as the experimenter, and then which one am I recording based on those adjustments, or which one can I change and then which one changes based on what I do. So the explanatory variable is the one we can change. It's the independent variable. And in this case, we're going to be able to figure out what distance we're starting at. And so the explanatory variable will be the starting depth. And of course, that's going to be in feet. And then our response variable is going to be how long does it take, based on that starting depth, how long does it take to drill 5 feet? So time to drill 5 feet. And that, of course, will be in minutes. So here is our data. I had to actually enter this data into StatCrunch manually because it did not come from our textbook specifically. If you want to pause and put the data in as well, you certainly can. I've got it in StatCrunch on the next slide. All right, so next we want to draw a scatter diagram or a scatter plot of the data. And of course, we'll do that with StatCrunch. And there's actually two ways to do this. I'm going to show you just drawing the scatter diagram. And then later on, I'll show you how we can get it along with our R value. So here is my data for the drilling depth that drilling began versus the time it takes to drill 5 feet. So again, to do a scatter plot or a scatter diagram, I'm going to go to Graph, click on Scatter Plot, and select my two variables. When I click Compute, I get a lovely diagram. This is a little more spread out than the one we saw earlier in the video, but still it looks like, for the most part, the deeper the drilling begins, the longer it takes. Now, of course, we have, some that don't quite follow that, but for the most part, we see that pattern. For part C, we're going to identify whether or not there is a linear correlation between these two variables. All right, so this question wants us to find out if there's a linear correlation between the depth at which drilling begins and the time it takes to dry drill a distance of 5 feet. So of course, with our data, what we're going to do is go in and calculate that linear regression or linear correlation coefficient under the regression portion of the stat menu. So I'm going to click Simple Linear and select my X and Y variables and then compute. Remember, this gives us a lot of extra data that we don't need. The only thing we want is this R value. Now, we have to be careful because just finding the R value doesn't tell us whether or not we have a relationship or not. We have to take that R value and compare it to our table value, which is actually fairly small compared to what we have. So our R value, which is 0.773, is definitely greater than the critical value, 0.576. So there is a linear relationship between these two variables.